Let's talk about what happens if an exception gets thrown deep inside nested function calls. So I have a piece of code here that's similar to the last example in the previous video. It's sort of a modified version of that. We have main, which creates a variable called y, and then initializes y to 0. I guess maybe we'll set that to something more visible. And then it sets y to be the result of a function call. And I might advise you can pull up the posted version of this on the side because I have to do a lot of scrolling in this example. And then at the end, I print out the value of y. The function g does some contrived task. So it creates a variable, uses some meaningless loop to compute some answer, and then returns it. But of course, nowhere in g is an exception thrown or caught. In the middle of the loop, though, on line 19, we call a function f, and the function f throws an exception. Notice how it only throws the exception if x is greater than 10. And if we sort of stare at this a little bit, if I pass in the argument 6, this loop will run at least once before any exceptions get thrown. But at some point, the function f will throw an exception. And it might actually be helpful here, maybe I should have done this in advance, to add some code that just prints out what's happening at each step. So whenever I call f, I will print out the value of x that was passed in. And then I will, every time I'm inside of g in the loop, inside loop in g, I will print out the value of y, just to get some flavor for what's actually happening here. And what we can see is we start in main, we call g with the argument 6, and then we end up here in g. And so we pass in, so we start inside the loop, 6 is less than 100, so I print out inside the loop in g, the value is 6. I then call f using the value of y, which is 6, so f prints out that it's 6. And then I go around the loop again, y equals 2 times y, that means that y will end up equaling 12 when I'm done. I go back up to line 19, I print that I'm inside the loop again, there's 12, I call f gets the value 12, and then a runtime error gets thrown. So in f, when the value is 12, we end up in this if statement where x is greater than 10, and I throw a runtime error. And who cares? This is all a contrived example, but what I wanted to illustrate was, of course, that if I throw an exception deep down inside of a function call, it still gets thrown and somebody still has to catch it. And I can sketch, like I did in the previous video, sort of what's happening. So here's main, and main has called a function g. And the expectation, so this is main called g, the expectation is that g is going to return a value to main, because under the normal flow of control, that's what we expect. G, in the middle of its operation, calls a function f. Okay, so there it is. And again, f is expected to return something. But in this case, when the value is 12, it doesn't. So f instead throws something. And when f throws something, it doesn't get returned by the normal path of control. Instead, I like to represent it as sort of f sending up a flare. And then when it's thrown, the idea is once any scope throws something, the thrown object will continue backwards through all the scopes that we've seen until somebody catches it. So we will end whatever scope it's in, and it will keep ending scopes until it hits a try block that's able to catch it. So in this case, on line 12, when I throw that runtime error, we go looking and say, well, what scope are we in? Well, we're actually in the scope that started on line 11. Is this a try block? No, it's not. So there's no way that this scope can catch the exception. Okay, so what about the scope that that's in? That's the scope of f. Is this a try block? Well, of course it isn't. It's a function. So we keep throwing. That means that f ends, and the exception gets thrown backwards. Okay, so it gets thrown to wherever we left off in g. Here I am in g. On line 21, am I in a try block? Well, no, I'm in this loop. Can this loop handle an exception? No, it can't. So the loop immediately ends, and I go to the scope containing it. Okay, is this a try block? Also no. So g ends, and the exception gets thrown backwards further. Okay, so we go back to where g got called. Here we are in main. In main, I ask, okay, the scope I'm in on line 30, is that a try block? No, so main ends. And the exception gets thrown back even further. And as I mentioned in a previous video, and as you might remember, I'm clearly way too excited about exceptions. Outside of main, so I mean, we could always ask that philosophical, metaphysical question of, wait a minute, main calls g calls, but who called main? Well, it turns out somebody did call main. Main is an ordinary function. Somebody did call it. It's hard to really describe what happened because it's like asking what's north of the North Pole. When you're inside of a C++ program, it's hard to know how things work in the outside world. Now, those of you taking 116, some of you are actually probably taking a course where you talk about how operating systems and programs work at a low level. So, of course, in architecture, for example, you might know more about what's going on here. But fundamentally, somebody called main originally, and they are responsible for what happens when main returns. So if an exception leaves main, it makes its way back to the operating system or whatever is outside of main, and then it's stopped there. And that is who generates this message. We've seen already that we can catch exceptions, but we never generate this specific message, terminate called. That all seems to be done outside of our control. So what's happened here is an exception has been thrown, and it's made its way all the way back across multiple scopes and functions, and nobody ever caught it. And so, of course, the program just ends. If the operating system ever gets an exception thrown out of main is over. The program has to end. So what do we do? Well, we could catch the exception, obviously, so let's try doing that in main. So here's my try block. I will try, the exception type here is runtime error. So I'm going to catch a runtime error. All right, and I'm going to illustrate where I catch it here. So I'm going to, let's see out, caught a runtime error in main. And I'm also, just like in the previous video, I am going to add a print statement here to indicate the case where the try block does finish successfully. And actually, maybe I'll do that. I'll also illustrate that that happened in main. All right, and so in this case, we still get the same readout as before, but then we don't get the program crashing as it did up here. We instead say, caught a runtime error in main. And so I'll have to redraw my diagram, but here's main, and over here it calls G, and G calls F, and F is the function that sends up a flare. And when it does this, the exception works its way all the way back to main, but main does catch it. So main does have a way of intercepting this exception, and it ends up sending control back into main. And that's how we end up on line 34. So at some point, and I'll just briefly retrace what we did before, I throw this exception, I look at the scope I'm in. This is not a try block, so the scope ends. This is not a try block, so the scope ends. So I get back to G. This is not a try block, so the scope ends. This is not a try block, so the scope ends. I end up back in main. I'm on line 31. This is a try block. It can catch this exception, and so we jump down to the catch block, and the exception is now extinguished. So that's what we ended up doing here. And so we threw the exception backwards across scope after scope until somebody caught it. And remember that if nobody catches it inside of the program, there is that catcher of last resort, which is the operating system from outside. All right, so what happens if we catch it sooner? So where's the soonest that we could catch the exception? Well, actually, we could do something like this. So one thing we've been seeing so far is we keep writing functions that throw exceptions. And it's really easy to develop, a misconception that the only place to throw an exception is when a function can't do its job. And in general, every time you throw an exception, the function always ends. That is not true. In general, you will keep ending scopes until you hit a try block. So if I wanted to, I could do something sort of absurd like this. I could throw an exception in the middle of a try block in the function where I'm throwing the exception. So I'll try something like this. Caught a runtime error in F. And I just realized that if I do it this way, I'm going to get a lot of output because this loop in G is going to run for a very long time. For the sake of not looking like I have something up my sleeve, I am going to run that and show you the horrible output. And you can see there's just a lot of stuff there. I don't know if it's that bad. Okay, so maybe I was going to think maybe we should shorten the loop in G a little bit, but that should be fine. So I call this function F, and what I'm really doing here is F is sending up a flare and then just catching it itself. Right? So I generate this exception on line 13, and then I begin looking at the scopes. I say, is the scope I'm in a try block? Yes. Okay, good. So we're done. Just catch it. We're done. on line 15. I go to the catch block on line 15, and then I return x times 10, because the function has handled the exception. As soon as the exception ends up in a catch block, it's been neutralized. The exception is now done. Now, one thing I should observe, which I'll talk about in a minute, is I could throw another exception inside my catch block, and that would not necessarily also be caught. And we find that we actually do that occasionally. In the next few videos, I'm going to do that a couple of times. Okay, so where else could we catch it? Let's get rid of this. This is a bit absurd that we would have a try block for the sole purpose of throwing an exception. But what if I tried something like this? And it turns out that mechanics like this are odd, but they do show up every now and then. I could have a try block in F where an exception is still thrown somewhere in the middle of the try block, but not as the only contents of the try block. So I could have something like this. The ultimate effect would be pretty much the same as what I had in the previous example, but this is also valid. What would happen if the exception is thrown here is we look at the scope it's in. We'd say, okay, is this scope a try block? No. Okay, so we look at this scope on line 11. Is this a try block? Yes. The second question is, can this catch the exception that I'm working with? And the answer is also yes. And so we'll try running this. Caught a runtime error in F. There we go. And if we run this, we'll notice that we get the same output because the effect is basically the same, because we still do the if statement and everything else. And we get the same answer at the end for y. But what if I try this? So what if I don't catch a runtime error, so caught an out of range exception? So in this case, just because I'm in a try block doesn't mean the exception always gets caught. So what's going to happen here is similar to what we had initially, which is I throw the exception on line 13, and I look at the scopes it's in. I say, okay, so is this a try block? No. Is this a try block? Yes. But can this try block catch the exception I'm dealing with? Well, I'm dealing with a runtime error. This try block can only work with out-of-range exceptions. So this try block can't help me. So in this case, the try block ends and the exception travels backwards as it did before. Just because I'm in a try block doesn't mean my exception will get extinguished. Only if I catch the specific exception that I'm working with, or if I have a catch-all block, will the exception be guaranteed to be extinguished. Otherwise, it just keeps traveling backwards. So we'll try that version. And we can see we're back to sort of our initial version where everything has to end. Every function has to end because nobody catches the exception until main. Okay, so I'll undo that, and we'll take a look at what happens if I catch the exception in G. Okay, so there's my try block. We'll get rid of that. And then here, so here I get inside the loop in G, and now I guess we'll start by trying this one. So what if the operation of G is, like all of the important stuff, is all inside of a big try block? So I'm going to catch if one arises. I'm going to catch a runtime error. And if I catch the runtime error, what can I do? Well, I have a few options. I think I'm going to start with just printing a message and doing nothing. So caught a runtime error in G. There we go. And I've removed the try block in F, which means I should have a similar situation to what I had before, which is that I get inside the loop in G, and then at some point an exception gets thrown, but unlike in this previous output, it gets caught in G and not inside of main. So we'll try running that. And we can see here, it caught a runtime error in G. So we got to the same point in G, but then it caught a runtime error. But notice what we have down here. So because I caught the runtime error in G, there was no exception to catch on line 35. G was able to regain control. It could right the ship. And so we see end of the try block in main, and then Y is 60. So, okay, why is 60 and not something else? Well, I think what we should care about for now is that it's not 999. This assignment was successful. It actually performed a modification of Y. And that's because G created a value for its result, tried to run a loop, got stuck or an error occurred, it caught the error, but then we exited the catch block and G returned a value as normal. So the error did not leave G. And that would correspond to this case here. So F sent up a flare, F sent up a flare, and then it made its way back to G. G caught it. And so control ended up in G. Control ended up on line 26 in that catch block. And of course, and I guess maybe we'll trace the whole exception backwards. So I generate the runtime error on line 12. I look at the scope it's in. Is this a try block? No. Is this a try block? No. So F ends and the exception keeps going. Okay, line 22. Is this a try block? Well, what scope are we in? We're actually in this scope here. Is this a try block? No. Okay, so the loop ends. Is this a try block? Yes. Can it catch a runtime error? Also yes. So the exception gets caught here and is extinguished. And so then on line 27, we just continue with G and then return a value as usual. Before I try a modification, I want to try this. So what happens if I throw another runtime error? So I'm going to throw runtime error, G has a problem. So one thing to understand, one very important thing to note, is that the only time an exception gets caught is when you're in a try block. If I throw an exception from inside a catch block, well, let's take a look at what would happen here. So I generate a runtime error. I ask the question, is this scope a try block? No. Okay, so is this scope a try block? No. Okay, so I go back down to where I called G on line 36. Is this a try block? Yes. Can it intercept a runtime error? Also yes. So in this case, we would have, we would end up actually catching an exception in G and then throwing a new exception in G and catching it in main. So here I caught a runtime error in G and then I generate a new runtime error for some reason. You might also see I could just throw the same runtime error again. I have a name for it. I could just throw E, but here I throw a brand new runtime error. That means that G does not finish successfully. So when I go down to main, this assignment gets interrupted because an exception got thrown out of G, it gets caught here. And so I see caught a runtime error in main, Y is 999. So just because I'm in a catch block doesn't mean I can catch an exception that gets thrown inside of it. The only thing that can catch exceptions is a try block. And it's worth considering that even if I did something odd like this, so suppose I throw out of range. This is a very common trick on midterm questions. So suppose I have a catch block for out of range here. And so this try block now has two associated catch blocks. One of them that catches a runtime error, and as soon as we catch the runtime error, we throw an out of range exception. But I have a catch block for out of range exceptions down here. Is this where I end up after line 27? And let's see if we can just follow the logic through. So we'll start in F. I throw a runtime error. And I ask, is this a try block? No. Okay, so I end the scope. Is this a try block? No. So I end the scope. I end up on line 22. Is this a try block? Well, no, it's a loop. So no. So I end the loop. Is this a try block? Yes. Can it catch a runtime error? Also yes. So I get down into line 26. I print out that I caught a runtime error. I then throw an out of range exception. Okay, so I threw something. Is the current scope a try block? No. So I end the current scope. So I don't go into this scope because this is just part of the same stack of try and catch. I end the catch block and I ask, is this a try block? No. So I end G. I end up in main. Is this a try block? Yes. But can it catch an out of range exception? And it turns out that it can't. So this scope ends, and then main ends, and then the program ends. And so I should expect to see the error from the operating system here. And there it is. So I caught the runtime error in G, and then I threw this out of range exception that nobody caught, and it made its way all the way back behind main. So what's happened here is sort of F threw something, G caught it, and then G threw something, and it made its way back past main, and the operating system caught it. And so the program had to end. So just because I throw an exception in a catch block doesn't mean that the same stack of try and catch blocks can catch that exception. In general, a try block is the only thing that can catch exceptions. The catch blocks define what you do when you've caught an exception. They themselves don't do the catching. Okay, so I'm going to back this up a bit. I have one more thing I want to talk about with this example. So we get back to this case where I am now able to, I want to catch the exception in G, but this time I want to catch it inside the loop. So what I'll do is this. I'm going to add a try block inside my loop, and it's valid to do that. You can put a loop inside a try block. You can put a try block inside a loop. Every time we get to the beginning of the try block, we run the try block and catch any exceptions that we can that show up in the middle. So I'm going to say, I'm going to catch my runtime error here, and I'm going to print out that I caught a runtime error in the loop in G. Okay, so what's going to happen here is I'm going to run the loop. At each iteration of the loop, I'm going to attempt to update my result variable by calling F. If this fails, we know already that if it fails, the the assignment never occurs. If f generates an exception, we don't do the left-hand side of the assignment. We just stop immediately and jump into the catch block. But notice that when I do this, once I catch this exception, the exception is then resolved, and then I just continue the loop. So the loop is going to keep running, even though an exception occurred and was handled in the middle of it, and that's valid. We can see here the value that I return for, so I'll start at the bottom. In main, notice that I do not catch any exceptions in main. I get to the end of the try block and I print out a value for y. The value is 60. You can verify to yourself, maybe skim over the posted version, that the value 60 is what f returned the first time around. So when g was called, the value of y was 6. The very first time I called f, there wasn't an exception, and we can verify that by looking through this. So I first get inside the loop in g and I call f. Notice that I do not catch a runtime error. So f returns the number times 10, so 60. So my result will now be 60. Every other time the loop runs, and the loop keeps running, I keep trying to call f, and f does get called, but it doesn't finish successfully. I keep throwing runtime errors and catching them. So the loop keeps running, but the value that I return from g ends up just being 60 because I never update my result variable again, because every time I try and call f, it throws an exception. And so what's happening there is we, again, throw the exception in f. We ask the question, is the scope I'm in a try block? No. Is the scope I'm in here a try block? No. So I get inside, back into g on line 22. Is this a try block? Yes. So I then ask the question, can I catch a runtime error here? Also yes, and so I do. And once I'm done with that, at the end of the catch block, I get down to line 26, and the loop continues as normal. So G was able to write the ship inside the loop, and the loop keeps running. So I can throw an exception anywhere, and I can catch it anywhere. Ultimately, how I catch exceptions is based on scopes, not specifically function boundaries. Although, broadly speaking, it's sort of odd to have an exception thrown inside of one function and caught elsewhere inside that function. It is, though, a valid thing to do. So as an illustration of why we care about this multi-layer situation, where I might throw an exception in f, and it might make its way all the way back to main, I could take another look at this function here. So here's a function we saw in a previous video when we were talking about function overloading. I've only sampled one version of it, but you maybe can see how I would update the other versions of it. The question is basically, what do I do? This is the function that returns the last element of a vector. And we can see here, I have a vector w with 6, 10, and 17. It returns the number 17. So what do I do if you pass in an empty vector? So we've seen, this is an example of the function being in an impossible situation. What do I do if you pass in an empty vector? Like, how do I deal with that? Well, obviously I can't return the last element, so what do I do? Actually, what I'm going to do here is, I want to save the version of the vector that actually has something in it in case I want that later. So we'll just comment this out and then make an empty vector and try using that. So if I pass in an empty vector, what should I do? Well, obviously we stare at this and say this is the week we're talking about exceptions build. It's pretty obvious what we're going to do here. So I ask the question, if input.size is equal to 0, well then clearly I'm out of luck. I could throw, I don't know, maybe I could throw out of range, because it is sort of out of range to try and ask for the last element of something that doesn't have any elements. So an empty vector has no last element. All right. I'm not even going to bother catching it. I think you can agree by now that I can catch exceptions. So I try running it, and we can see, yeah, it throws an instance of out of range. Okay, great. But actually, we should ask ourselves the question. So first, one question that I'll answer in a minute is, wait a minute, is out of range really appropriate? Why not use invalid argument? That's a good point. I'll think about that in a minute. But also, what if I didn't do that? You notice I wrote the solution without actually trying the function without doing that. So let's try it. What happens if I execute this function without actually throwing that exception myself? So I'm passing in an empty vector, which obviously has no last element. And I notice, hey, what I ended up throwing was out of range. The function still throws an out of range exception, because what I'm dealing with here is I'm in main, and I call the last function. And the last function calls the .at function. And the .at function, as we know, if we provide an index that makes no sense, and on an empty vector, every index makes no sense, but of course, this really doesn't make any sense. When I provide an index that makes no sense, we know already what .at will do. .at sends up a flare. It can't return an element when there is no element, and so it throws out of range. And in the way the code is written right now, last doesn't catch it, and so it makes its way back to main. So if I want the last function to throw the out of range exception when the vector is empty, I don't need to do anything at all, because an exception is already getting thrown for me by .at. I can just let that slip through. And then I get my out of range exception. Now, if I don't like the error message, I could add my own. I could either add my own by throwing an exception myself, or I could sort of do it in a cheeky backdoor way like this by saying, okay, first try to, get that index and return it. And if we catch an out of range exception, then I will just turn around and throw my own std out of range exception. And I'll say empty vectors have no last element. I don't think that was the text I used last time. And then we'll sort of strategically scroll to put everything on screen at once. And so what I'm doing here is I'm catching the out of range exception and just throwing my own out of range exception. I'm just transforming it into a better looking out of range exception. I could also choose to convert the out of range exception to std invalid argument. I could say, actually, in the context of this, out of range makes no sense. Instead, you passed me an invalid argument. I'm going to throw the invalid argument exception. And so I sort of trade in one exception for another. And I'm allowed to do that. Now, that said, this is an interesting contrivance, but really, if you were writing a function like this and you wanted to throw an exception, I would recommend doing it the way I started with, which is it's generally better to if you can proactively check for an error. So if there's an easy way of proactively checking, like this, where I just ask a question, I don't bother trying and catching. If there's a proactive solution, it's often better to do that. It's better to write code that proactively prevents the error from occurring, and in this case throws an exception before .at has a crack at it, than it is to use a try and catch. Although both are valid, you'll find it's considered to be better practice to be proactively checking errors when that makes sense. It doesn't always make sense. There are times when it makes more sense to let the operation fail. But in a case like this, it's pretty easy to do that check yourself. And so I think it makes sense just to do the check with an if statement beforehand.